Okay, this is example number 2. On example number 2, what's going to happen is you're going to be given a trig expression. If you remember back, like with just basic algebra, the difference between expressions and equations is expressions is just kind of like some math junk here that doesn't have an equal sign to it. So it's just some math stuff. And what we're asked to do is simplify, which I underline the word simplify. So simplify means this is a little bit messy and it can be cleaned up a bit. When I look at this, what I see is 2 pieces. It's not 3 pieces. It's not 1 piece, 2 piece, 3 pieces. In algebra, your pieces or your terms are separated with plus or minus signs. So this subtract sign means all this is a piece right here, and this is a piece right here. So what I want to do is look and see if I can find something in common between the 2 pieces. What I have is they both have a sign x on them. So when you look at your 2 pieces and they have a thing in common, what we can do is we're going to factor off, or think of it like let's undistribute from it. Just a thought. So here's just a random thought over here. So here's a thought. It's my thought bubble. Random thought here. If you had, say, let's say 4x minus 12. This is something you might have seen in Algebra 1. 4x minus 12. And we wanted to undistribute, or you wanted to factor this. You'd look at what number you have in common between both of them. And you go, oh, I can divide this by 4, and I can divide this by 4. So you'd go 4, and then you'd go, okay, this ends up being x, and then this ends up being minus 3. So if you redistributed it, you get 4x minus 12. So this is undistributing. Or factoring. I think most teachers would probably say that the other way. This is factoring or undistributing. Either way, that's what we're going to do, but you have to do it. It's going to be a lot harder because we're doing with like trig stuff here. So what we want to do is you're going to pull off or undistribute this sin x. What that means is we're going to write sin x, and then we're going to put a parenthesis down. So I'm going to write sin x, and I'm going to drop this parenthesis. And then I'm going to look at each term. So the first term said sin x, cosine x. If I pull the sin x off of it, I just have the cosine squared x. Then the next thing is I'm going to put the minus sign in there. You would end up with a 1 there. And now look at this. If you redistribute it, sin x times cosine squared x gives you this. And sin x times negative 1 gives you this. So that is us just pulling off a sin x. Now the next thing we have to do is this gets simplified a little further, and what's going to happen is this is going to get simplified using our identities. So what I've underlined there, this kind of pink cosine squared x minus 1, I'm going to simplify it using my trig identities. Now I want to go to that one I've said many times is the most important one, the Pythagorean identity. Sine squared u plus cosine squared u equals 1. I'm going to write it down over here. So that was this was one thought. I'm going to have another thought over here. So let's get another thought going. I'm getting lazier on my thought bubbles here. I'm going to write down sine squared, and heck, I'm going to do x. I just like x better than u. Sine squared x plus cosine squared x equals 1. That's the identity. Sine squared x plus cosine squared x equals 1. Now, when they give you this identity, you can use any of those algebra tricks that you've ever learned to kind of manipulate it so it looks differently, and it'll still be an identity. So what I want to do is I want to manipulate this identity so that part of it looks like this. And when I say part of it, that means either the left side or the right side somehow looks like cosine squared x minus 1. Alright, so here's how I'm going to do it. I have cosine squared x, and I'm going to move this 1 over to the left. I'm going to minus 1 on each side. So now I'll have sine squared x plus cosine squared x minus 1 equals 0. And I'm going to finish it off. This is what I wanted right here, the cosine squared x minus 1. So I'm going to move the sine squared x over to the other side like this. And now that identity that I started with looks a little more like this. That's negative sine squared x. It's like I've created a new identity. I took that one really important one and I've created a new identity. One of the most important things we do with identities is it allows us to make substitutions. So anytime you're working a problem, an expression, or an equation, if you ever come across a cosine squared x minus 1, you are allowed to substitute it with one of these. So you can make this go away and put this in its place. So let's go back to the problem that we were working on. After we factored out or undistributed the sine x, we had sine x, and then a parenthesis, cosine squared x minus 1. This thing we did on the side note here says if you ever see a cosine squared x minus 1, you can replace it with a negative sine squared x. So watch how as we apply that here. This right here can be substituted out. So what I'm going to have now is I'm going to have a sine x, and then I'm going to make a substitution here, and I'm going to put whatever I'm allowed to sub in here. So cosine squared x minus 1 can be replaced with this, negative sine squared x, there. And the reason I put the parentheses is I don't want you to get confused. I don't want you to think it's sine x minus sine squared x. That's a totally different thing. It's actually sine x times negative sine squared x, so that you can actually multiply them together. And if you have sine x and you have sine squared x, that multiplies together and just makes sine to the third x. But don't forget, since this one's negative, it's positive sine x times negative sine squared x. And there is your final answer. It's negative sine to the third x. So think what we did real quick. We started out with this right here. Sine x, cosine squared x minus sine x. We pulled out a sine x, undistributed out sine x, so it's sine x, then parenthesis, cosine squared x minus 1. It's undistributing. If you redistributed, you get what you started with. Then we used our fundamental identities, and this is not a fundamental identity, but we were able to take that one right here and manipulate it so that we could give ourselves permission to swap out cosine squared x minus 1 and replace it with negative sine squared x. So we did that, and then we just multiplied. Your sine x and sine squared x makes sine to the third, and then it just happens to be negative. All right, so that's example number 2.